Hello, dear students in grade 8. This is a new mathematics lecture, and as you can see, it's lecture 11, and the title of our lesson is Fractional or Rational Expressions. First, we will define a fractional expression. Number 2, identify the domain of definition of a fractional expression. We will say when is a fractional expression defined or exists. Number 3, we will simplify or reduce a fractional expression. First of all, I'm reminding you of the methods of factorize an algebraic expression because we still need them. They are very important. We have the common factor, we factorize using common factor, or we factorize using one of the 3 remarkable identities. So please never forget these rules and always revise them. Fractional expressions. What is a fractional expression? A fractional expression is a fraction or a ratio in which the numerator and denominator are both algebraic expressions or polynomials. And this is how we write a fractional expression. A fractional expression is a numerator over denominator, where the numerator is an algebraic expression and it should be written in factorized form, not expanded form. So the numerator should always be written in factorized form, and also the denominator is an algebraic expression and it also should be written in factorized form. So this is very important. In a fractional expression, the numerator and denominator should be algebraic expressions in factorized form always. As an example, we have a fractional expression h of x. The numerator is factorized. 2 binomials multiplied together, 3x minus 1 into x plus 4, and the denominator is 2 binomials multiplied together, x plus 1 into x minus 2. So this is called a fractional expression. Another example, if I gave you 2 algebraic expressions, a of x is x into 2x minus 1, it's factorized. B of x is a 3x minus 2 into 2x minus 1. So a of x and b of x are both written in factorized form. And I told you, let e of x be equal to a of x over b of x. So I should write e of x, I should replace here the factorized form of a of x in the numerator and the factorized form of b of x in the denominator. So in e of x, we replace the factorized forms of both the numerator and denominator. So I get x into 2x minus 1, 3x minus 2 into 2x minus 1. This is how we write e of x as a fractional expression. When we talk about a fractional expression, always we have something called domain of definition, condition of existence. In math, any fraction exists only if its denominator is not 0. Because in a fraction, if the denominator is 0, the calculator will give you an error. I want you to try, for example, 3 over 0 or 3 divided by 0, the calculator gives you a mathematics error. This does not exist in math. So any fraction to exist in math, the denominator is different from 0. So a literal or a fractional expression exists or is defined if its denominator is different from 0. Never forget this. So before doing anything with a fractional expression, we start always from the domain of definition. For example, if I gave you this fractional expression and I asked you, when does it defined? We say this fractional expression is defined or exists if whatever I have in the denominator, I have a plus 3 should be different from 0, then a should be different from, I take the plus 3 to the second side, it's different from minus 3. I gave you this fractional expression. When does it exist? It exists if whatever I have in the denominator, x minus 2 into x plus 2, different from 0, we solve this as if we are solving a product equation. Equal and different from 0 are the same. So x minus 2 is different from the 0, x is different from 2, and in the domain of definition, both factors should be different from 0, and x plus 2 should be different from 0, then x is different from minus 2. After we write the domain of definition of a fractional expression, we simplify or reduce a fractional expression. To simplify a fractional expression, first, as I said, we write the domain of definition whatever you have in the denominator should be different from 0, and we find a common factor between the numerator and denominator, then we divide both by the common factor. For example, I have a fractional expression e of x, which is m minus 1 squared over m minus 1 into m plus 1. The question here, I should simplify, but I cannot simplify unless first I write the domain of definition. So I say e of x is defined if whatever I have in the denominator, m minus 1 into m plus 1 is different from 0. So m minus 1 is different from 0, m is different from 1, and m plus 1 is different from 0, then m is different from minus 1. So this is the domain of definition. Now I write again a of x, and now I see what is the common factor between the numerator and the denominator. As you know that m minus 1 squared is written m minus 1 into m minus 1. So we can see that I have a common factor, which is a binomial m minus 1 in the numerator and a binomial m minus 1 in the denominator. These two common factors cancel each other. So I'm left with m minus 1 over m plus 1. This is called the simplified e of x. Let's solve an example. We are given h of x, which is x minus 3 into 2x minus 1 over 2x minus 1 into 2x plus 3. The first question is, for what values of x is h of x defined? So we answer h of x is defined if, as I said, whatever I have in the denominator should be different from 0. So 2x minus 1 is different from 0. I solve it. 2x is different from 1. Then x is different from 1 over 2. And 2x plus 3 is different from 0. Then 2x is different from minus 3. So x is different from minus 3 over 2. After I wrote the domain of definition, I should simplify h of x. So I look, what is common between the numerator and denominator? There is a common binomial to x minus 1. So 2x minus 1 cancels to x minus 1. So I'm left with x minus 3 over 2x plus 3. This is the simplified h of x. Now solve h of x equal to, which h of x do I replace here? I replace h of x in the simplified answer. So instead of h of x, I write x minus 3 over 2x plus 3 equal to 2. This is a fractional equation. We used to solve this before. 2, since the first side is a fraction, so I should write the second side as a fraction. I write it 2 over 1. I do the cross multiplication, numerator times denominator equal denominator times numerator. This is a first degree equation. I should get rid of the parentheses by expanding. So I have x minus 3 equal 4x plus 6. Now all x to side 1, all numbers to side 2. I calculate side 1 minus 3x equal 9. This is the simple equation form. Now I write my answer, which is x equal 9 over minus 3. Then 9 is equal to, of course, here I have a typing mistake. This is x equal minus 3. So this should be minus 3, and always I put my solution, of course, in a box. Okay, so this was our lesson for this week. As you can see, this is a very small lesson. And always you should revise how we factorize, the rules of factorizing an algebraic expression, because these are very important. So as I said, this was the title of our lesson. Thank you. If you have any question, please contact me.